Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students in functions and relations who are working on the summative. It's question number 8. A triangular piece of wood is to be cut with side lengths 5, 6, and 7 centimeters. What angle measurements does the carpenter need to draw? Round answers to the nearest tenth of a degree. So I have a triangle, and certainly I know I'm a very visual learner, so I need to kind of visualize what's going on. There's a triangle, and I'm not trying to draw it properly or to scale or anything like that. I just want a triangle. And also, because there's no indication about how to label my triangle, I'm going to pick my own labels. Yay, A, B, and C. And now, what do I know? So it's a triangular piece of wood, and the side lengths are 5, 6, and 7. So it doesn't really matter how I label it. I'll just say 5, 6, and 7. What angle measurements does the carpenter need to draw? So I need to know what are the angles in this triangle. Okay, pretty straightforward question, I hope. So how am I going to figure those angles out? Well, there's no 90-degree angle, so I can't use the basic trig ratios of sine, cosine, and tangent. The sine law, if I wanted to use the sine law, if I wanted to use the sine law, I would need to know one of these pairs of angle with opposite side. And since I don't know any angles, I can't use the sine law. So I'm left with the cosine law. And the cosine law is sort of your, if nothing else works, you got to go cosine law. And the cosine law is set up so that if I know an angle, I can find the side, but I'm sort of using it the other way. I know all the sides and I want the angle. So even before I do any substitution, I'm going to rearrange the cosine law so that I know that I'm solving for an angle. So in other words, what I really want to do is rewrite this equation so that the cosine C, the trig statement, is isolated so that I can figure out the decimal value of cosine C and then very quickly find C from there. And I guess since I labeled my triangle ABC, I might as well stick to that. I'm going to start by finding angle C so that I don't even have to rearrange this with any of the letters. I just need to rearrange it as it is. So how can I rearrange this? So again, the yellow box is what I need to isolate. So when I look at what's happening, I've got some multiplication. Negative 2ab is multiplied times cosine c. And then a squared and b squared are added or subtracted. So I need to first of all get rid of a squared and b squared. So I'm going to move them to the other side. Oh, that's some bad math communication. I'm going to subtract a squared and subtract b squared from both sides. So my first step of rearranging, oops, my first step of rearranging will be to subtract a squared and subtract b squared from both sides. So that's the first step. And again, this is what I need to isolate. So now what's happening to that yellow box, what's happening in cosine C is multiplication. And it's multiplication by negative 2ab. So to get rid of a multiplication, I need to do division. So my next step will be to divide both sides by negative 2ab. And when I do that, what I'm left with on the right is just cosine C. So that's the rearrangement, and now I'm ready to actually substitute into this formula and do some calculations. So I have c squared minus a squared minus b squared, all divided by negative 2 times a times b, and that will equal cosine c. So if this is the first video of mine you're watching, you'll notice that I do this with my formula, which is I rewrite the formula using blank brackets, and then I go back and substitute values into those brackets. And that's just to make sure that my brain is sort of focused on one thing at a time. So first I was focused on getting the formula correct, and now I'm going to focus on doing the correct substitutions. So side C was 6, and A and B are 5 and 7. So 5 and 7. And it doesn't really matter that this is A and B versus this is B and A. The math will be the same. As long as I got the C correct, then we're good. So now I'm going to calculate. So in the numerator, I have 6 squared minus 5 squared minus 7 squared, and that's going to give me negative 38. In the denominator, I have negative 2 times 5 times 7, and that's going to give me negative 70. And then dividing numerator with denominator. So 38 divided by 70, I get a decimal value of 0.5429, and I don't need to say this, right? You keep 4 decimals rounded correctly in a trig question. And just to go back here for a second, when I said I'm going to divide this in my calculator, I didn't say negative 38 divided by negative 70. I just said 38 divided by 70. You should, at this point in your math career, be aware of whether or not your answer is going to be positive or negative. A negative divided by a negative is a positive. Certainly, you can type in exactly what you see, but you should also be kind of more broadly aware of what's going on mathematically. So I inverse cosine this value, and I get that angle C is 57.1 degrees. So what do we know? If I go back to this diagram, I now know that angle C is 57.1 degrees. So I have one of the angles in my triangle. I need all the other ones. So now is when I can use the cosine law. The sine law. Because I know both angle C and side C, I can use the cosine law perfectly fine. So let's go ahead and do that. And you know what? I'm going to move it to a new page. So new page. Now the one that I know is C. So the way that I like to set up the sine law is the partnership that I know, which in this case is angle C side C, I put it in the middle. And I'll show you why in a second. It's not something that you have to do at all. It's just the way that my brain likes to keep things organized. So there's the sine law where I know both C and C, so I know angle C and side C. And the reason why I like to set it up like this, it's just, for no reason at all, except for I can clearly see that there's one relationship here where I can solve for missing angle A, and then I can come over here and I can solve for missing angle B. That's why I like to do that. So let's go ahead and substitute in the values that I know. Do, do, do. So I'm going to do sine A over side A equals sine C over side C. So make sure I get those values right. This was 57.1 and this was 6. And side A was the side that I called 7 centimeters. Okay, so there's my proportion. So I'm going to solve by cross multiplication. So sine A times 6 is 6 times sine A, not much to do. And then 7 times the other sine. So 7 times sine 57.1. So I want to isolate the trig statement here. So I'm going to divide by 6 on both sides. So when I divide by 6, I get sine A equals 7 times sine 57.1. And that'll be divided by 6. And now I'm ready to type stuff into my calculator. So what do I get? Sine 57.1 times 7 divided by 6, 0.9796. So 0.9796. And then if I do inverse sine, I'll find the value of my angle. So I get that angle A is 78.4 degrees. So angle A is 78.4 degrees. Yep, looks good to me. So let's go back to my diagram. So this was 78.4. Now I know I could simply use the 180 rule, that the sum of the angles in a triangle is 180 to find B. And if I was under a time crunch, that's probably what I would do. But I prefer to actually leave that as a check of my math. So I'm going to find angle B the same way I found angle A, which was by taking this part of my sine ratio equation and solving for B. So sine C over C is sine B over B. And this was 57.1. This was 6. Oops. See, I messed up right there. I know what that is. I know that the measure of side B is 5. So now I'm going to cross multiply. So 5 times sine 57.1 is equal to 6 times sine B. So isolating sine B means divide by 6. So 5 times sine 57.1 divided by 6 is equal to sine B. And now I'm ready to type that into my calculator and get the decimal value of sine B. So sine 57.1 times 5 divided by 6, I get 0.6997. So 0.6997 is sine B. So if I inverse sine, I'll know the value of angle B. So angle B is 44.4 degrees. So let's go add that on the diagram. Purple. Sure. And now is where I would say, if I add all these angles, do I get reasonably close to 180 degrees? And just so you know, this is the second time I've recorded this video, because the first time I didn't get reasonably close to 180 degrees because I'd made a math error. But this time I get 179.9, so I'm pretty confident that those are the angles. Okay, I hope that was helpful, and good luck with your math.